Hello everyone, in this video we're going to talk about how to graph a system of linear inequalities. A system of linear inequalities is a set of two or more linear inequalities in the same variables. And an example that we see here, y is less than 4x minus 2 and y is greater than or equal to x plus 7. So just like we talked about with systems of linear equations, a solution of a system has to be a solution to both of the inequalities in the system, okay? So for our purposes, we're going to look at a system of linear inequalities that contains just two linear inequalities, okay? We are going to solve the system by graphing. The graph of a system of linear inequalities is the graph of the solutions of all the solutions in the system. So to find all the solutions, we have to graph each inequality in the same coordinate plane. So if you want to review how to graph linear inequalities, check out the video in the top right-hand corner. Step 2, we're going to find the intersection of the half planes, which is where our shading will overlap, and that will be the solution of the system of inequalities, okay? All right, so let's look at a couple examples. So we want to graph the system y is greater than or equal to 1. So we're going to start off by graphing that linear inequality. So -1, excuse me. So greater than or equal, so that's a solid line, and it's a horizontal line because it's like y equals a number. So horizontal line, and it's a solid line through -1. And it tells us now y is greater than or equal to -1. So that's going to be above this line because that's greater than, right, is above. But remember, we can choose a test point and plug it in. So if we choose the origin as our test point, we would say 0 is greater than or equal to -1, and that is true, right? So we are going to shade above this line, okay? So we'll shade this entire region, our whole entire graph, up here above this line, okay? All right, so now our next inequality, switch over to green here, we will graph y is less than -x plus 2. So -x plus 2, let's see if I can make my graph come back up here. All right, let me actually take this shading away for right now so that we can add in this point. So plus 2, 1, 2, and our slope is -1, so down 1, right 1, down 1, right 1, or up 1, left 1. So we can draw our line here, and we'll extend it going in the other direction as well. Now for this one, remember we have just a less than symbol, so we actually want to make this line be a dashed line. Okay, so now we have our second inequality graphed, and now let's shade depending on what our test point tells us. So we can choose the origin again. So let's plug in 0 is less than -0 plus 2. So 0 is less than 2, and that is true, right? So we are going to shade to the left of this green line. So, whoops. Okay. So we shade to the left of the green line, right? So this area here, just to the left of this green line. And remember, when we shaded the blue line, we wanted all of this region above the blue line. Okay. Actually, let me take that away. So let's do it like this. We wanted all of the region above the blue line. Okay. So this whole area up here. All right. But now, once we look at this, we can see the part that has overlapping shading, right? The part that is both green and blue. So if I take away this part, then just the section that is shaded with both green and blue would be the solution to my system, okay? All right, let's do one more. Okay, so we have x minus y is greater than 2, and x minus y is less than or equal to -3. So we want to have these in slope-intercept form. So for both of these, let's subtract x, and then we're going to divide by -1. Now we're working with inequalities here, so remember if we multiply or divide by -1, that's going to flip that inequality symbol. So this is going to become y is less than x minus 2, so that's one inequality. The second inequality, we're going to have negative y is greater than or equal to negative x minus 3. We just subtracted x to bring it over. And then we are going to divide or multiply everything by negative 1. So negative y becomes positive y, less than or equal becomes greater than or equal, negative x becomes x, and negative 3 becomes positive 3. So now these are the two inequalities that we're going to graph as a part of our system. So the first one is less than x minus 2. So x minus 2, there's negative 2, and we go up 1, right 1 as our slope. Okay? Or we can go down 1 and left 1. Just a less than symbol, so we're going to make this a dashed line. Okay? And we'll come back to the shading in just a minute. Okay, let's get both of our lines graphed here first. And we have greater than or equal to x plus 3. So 1, 2, 3, 1, 2, 3. And our slope, once again, is 1, right? So we go up 1, right 1, or down 1, left 1. So let's see if I can, there we go, I'll just do two separate sections again. And there we go. And this one will maintain a solid line because it was or equal to, okay? Now let's shade with the green line first, okay? So that's our second equation. So we can use the origin for the test point for both of these inequalities. So for the second inequality, we're going to say 0 is greater than 0 plus 3. So 0 is greater than 3. That is false, right? So we're not going to shade on that side because that's where the test point was located. We are going to shade on the other side of the line. Okay, so this whole region of the coordinate plane up here to like the top left. Okay? All right, now let's do the first inequality. We'll do it in blue. So we're working with that first equation, right, or that first inequality right there. Let's use the test point 0, 0 again. So we're going to say 0 is less than 0 minus 2. So 0 is less than negative 2. And once again, that is false, right? So we're not going to shade in there because that's where the test point is. We are going to shade this region on the other side. Okay, but now once we do this, this one looks a little bit different than the previous example because in the previous example, we said that the solution to the system was where the shading overlapped. Well, we don't see any overlapping shading on this example. So because of this, we're going to say that there actually is no solution. Okay, so that one was a little bit different because we didn't have overlapping shading. But if you remember from when we did systems graphing with equations, the slope was the same and the y-intercept was different, right? So that gave us parallel lines. And because of what our inequality symbols were, the shading was on the outside, right? The shading could have been on the inside and we would have a solution there. But since the shading was on the outside, there is no overlapping shading, then there is no solution. And that's how you graph a system of linear inequalities.